good afternoon, everybody. My name is Sebastián Arias, and I'm going to present my dissertation work regarding the automatic rule verification for digital building permit. This work was developed at the University of Minho under the supervision of Professor José Grange. And I would like to start just with this image because when I got to architecture school, I was just amazed of how the built environment can really shape societies. And it's not only shaping societies like physically, it's also creating jobs and creating companies and actually allowing just two communities to grow. And what we cannot see, because that's what we can see, but what we cannot see is how complex a construction project is and how complex it is to get to that built environment. And if we check just the RIBA plan, we can see that a project has several phases, and each one of these phases have like several sub steps that involve different stakeholders, different actors, and each one has its own motivation. So a project, it's at the end a mix and entanglement of different actors. So what could possibly go wrong with such complex projects? And the answer is many things, from overruns and overcost that it's really likely in the infrastructure sector of the economy, to really not providing and not adding much value, since our projects are so tailor-made, and not even like taking advantage of the new tools and the digital tools that are coming to every day. So the construction is one of the least digitized sectors of the economy. So yeah, we can say that many things can really go wrong, since it's getting more and more complex, because now the clients and the customers are getting more sophisticated and have different demands, and then the market is like presenting like more strict regulations that we have to comply, and we have to also integrate different type of technologies, the industrialization, materials, and actually the digitalization, the integration of these new technologies to our processes to become more efficient. So let's talk a little bit about the digitalization. So how can we just integrate these digital tools and this computing power to make our work easier, as Harris was mentioning? Let's just focus on one of the possibilities. We're talking about the building permit. And if we check, there is a need, and if we check just the headlines of many websites, we can see that there's a lot of applications for building permits, sorry, that are overcoming to the workforce available in the building permit offices. And as a result, we can see that the actual building permit process can take anywhere from 100 days to 400 days across the world. So the question is someone taking care of this? It's someone like really integrating digital tools to this subject? And the answer is yes. If we check, there's like several initiatives that mainly are focused on integration information models and geographic information systems to the regulation verification, and the usage of information models that is also like supported by governments and directives, such as the European Directive for Public Procurement, that is enabling, and it's actually helping more people to get into this digitalization process. Some more specific initiatives, such as CORENET in Singapore, CAIB in South Korea, HITOS in Norway, and Smart Codes in the US, are really focused on how to automate this verification, the rule verification for the digital building permit, to make the process quicker, and it cannot last like 100 days. And I would like to draw the attention to different groups that are really focused on taking the step to this digitalization, such as the European Network for Digital Building Permits, that is a group of researchers and people from the industry that really want to came up with a strategy for this digitalization to happen. As a result of this network and this exchange of knowledge, some research uh, have appeared, and this is actually the roadmap of my dissertation from the document unveiling the actual process of digital building permit, where we can see a comprehensive approach and on the workflow for the digital building permit. What would be the actual steps to take to digitalize the process, from the definition of the rules in the step 1 to the notification once the permit is issued in step 8. And for each of these steps, there's like opportunities to innovate and to improve. And actually, there's a lot of research going on regarding each of these steps. So if we've seen that there's a lot of research, then what could be like missing? And the thing is, most of this research is focused on the information from the IFC models, from the information models, and it's considering that information is correct. But if the information is not correct, we're lacking of methods to verify the correctness. We're missing some sort of certainty. So let's see, for example, what happens in Portugal. Portugal, we have different information requirements. This one is from the Instituto Nacional de Estatística. It's actually an information requirement for statistical purposes, but we also have different information requirements, and this one is the Cuadro Sinóptico, which actually requires information for classification and identification inside the permit office. So after analyzing the information required in this case, I classified it in two types: the attribute fields, which are like low complexity. Actually, it's information that you can include explicitly in the information model, such as the type of work or the scope of work. And there is some more complex fields that have a higher level of complexity, which are the quantitative fields that actually requires certain procedure for calculation, understanding the relationship between elements and entities, and that will require certain algorithm to extract information. An example of this can be the extraction of the area of implantation of a project that would require you to refer to the regulation to know how you're supposed to calculate that. So actually, who verifies this type of information? And if we check the traditional process, we have an applicant that can generate all the documentation, submit it to a platform, pay the taxes, and then that information is assigned to a permit technician in the permit office or a permit officer, who is in charge to check the completeness of the information, just to know that nothing's missing, and then validate the correctness of that information. If at some point he realizes that some of this information have an issue, it will ask for an amendment. If there's no issue, it will continue to the actual full verification. So what I'm proposing in my dissertation work is a hybrid approach that on one hand will just extract the information that is explicitly defined in the information model by the modeler, but on the other hand, and simultaneously and automatically, will check the correctness of the information based on the relationships and based on the definitions that are considered in the regulations. And this is a previous step before the actual compliance checking that will require some other type of algorithms. So yeah, this is the proposed process. So the applicant will generate a BIM model in the format of an IFC model based on some information requirements from the permit authority. And there's going to be a third actor that will be a server and will include a database where the information is going to be automatically checked. There has to be a permit technician to overview the process, but the verification and the validation of the information is going to be taken care of automatically. So if the information is going to be extracted on one hand, and then it's going to be compared to the implicit derived information based on the definition to calculate, for example, the area. And if the information matches, the information, it's assumed to be correct. So it's going to be a higher grade of certainty. If it's not matching, then the permit technician is going to have to check it out and then ask for the amendment. So this approach, looking for certainty, will include 3 of the steps of the workflow that was presented before. And in this case, just from the step 1, we will have to represent the requirements from the regulations. From the step 4, we'll have to define how the information model has to comply with those requirements and what are the characteristics that it has to have. And then on the step 5, we will check the overall quality of the model just in terms of correctness. So this is how it's done. And in the step 1, we will define the 2 types of attributes that I mentioned, the attribute fields and the quantitative fields. And then we will have to define this under the framework of the level of information need. We will have to define for the different IFC entities how the information has to be presented and delivered. And then at the end, we'll have a data template specifying exactly how the information has to be defined for the relevant entities. Then, of course, we can present this as an information delivery in the information delivery specification. But this technology is still under development, and hopefully it will be like implemented for IFC5. It will, because this standard will allow to define these requirements in a already machine readable way. So it will smoothen the actual process of automation in some years. So once the requirements are defined, then we will have to check the actual correctness of the information. So in my work, I use IFC OpenShell, which is a library for Python, to actually access the information, extract it, check the relationships between entities, and then from there, proceed with the validation of the correctness. So for example, if in the case of implantation area, which is a type of area defined in the regulation, the modeler will actually define the boundaries physically. In this case, it's with Revit. He will define the boundaries explicitly, and he will present the area based on the information requirements and the information delivery specification. Then he will export the IFC, and then this is what the actual algorithm will verify. On one hand, which is this lane, it's going to extract information, the explicitly defined information from the model. So if the modeler define a space, it will extract the information from that space. But on the other hand, it's going to follow the procedure defined in the regulations to actually extract again that information. In the case of the area, it will define the boundaries based on the walls, and it will extract the vertices from the geometries of the walls and slabs. And it will generate a second set of information to compare the explicitly one, the one defined by the modeler, and then the one following the algorithm defined and the definition defined in the regulations. If the information is equal in both cases, then the information is approved. If not, it's asked for an amendment. And it's better to show with a case study. This is a sandbox project, a residential building on 4 floors. And the information requirements were included, and the information required was included according to what was exposed in the dissertation. And how the actual algorithm would work will be that the permit officer will define from which levels the information will be extracted, and then it will start to verify. This is the case for the area, for example. So it will extract the boundaries of the walls, it will extract the boundaries of the slabs, and it will calculate the area, and then for then making a comparison. So in this case, uh, and it will do it level by level. In this case, is for implementation area. So it will start to extract information from the first level, the slabs, and then the walls, and it will just merge it and generate the actual surfaces to calculate the areas. This is just the case of the first floor, and it will generate the shape to be calculated and verified. It will generate it for every single floor, and I'm not going to stop in that. And this is the actual result. At the end, we'll have, on one hand, explicitly defined information, which was defined by the modeler, extracted, and on the other hand, implicitly derived information. And if the results from both is the same, we can actually assume that the information is correct. So the algorithm works, but it's still under development, and it has some limitations regarding the types of geometries and how the information it's supposed to be required. But it will reduce the time the building permit officials are taking for the building permit, and it's also contributing to a bigger library to actually have some methods to manipulate information contained in the IFC. I think that will be it. So thank you.